Number 22 is a little bit different. I mean, remember these are all vocab proofs, and we're using a vocab word, equiangular, that's not on your sheet. But do you know what equiangular is? Can we use what that is, or can you think of what that would be in a conditional statement? Definition of equiangular triangles. So what is an equiangular triangle? What, by definition, would be your conclusion if you knew it was equiangular? Well, you could say all the angles are equal. It kind of says in the word. So we're saying all the measures of the angles, by definition, are the same. So I can say measure of angle A equals measure of angle. Well, you can't say B because there's like 4 angle B's. So it's like, which one are you talking about? The left, the right, the top, the bottom? Well, we want the one inside the triangle, so we need to use our 3 letters. From A to B to C would trace the one we're looking for, so measure of angle A, B, C. And the third angle is measure of angle C. And so that's what they're giving us. They're trying to lead us to know that those 3 measures are the same, and somehow we're supposed to know that A is going to be congruent to angle 1. So how does 1 get tied? I already know that measure of angle A is equal to the other 2. How do you tie 1 into the picture? Well, there's a couple things we look for when we don't have any, like we're stuck and we don't have enough to get all the way through a lot of times with these vocab proofs. There will be some others later, but for now, linear pair. Maybe there's a line, there's a couple angles that form a line. They don't have to tell you that. We can see that if they give us that in the picture. Here, it's not a linear pair. I mean, we have a couple linear pairs, but that's not how we're going to tie 1 to the triangle. We're going to take 1 and say that that's going to be the same measure as, just like if you're doing an angle puzzle, measure of angle ABC. So I'll give you a moment to think about that. How do we know that measure of angle 1 is the same as measure of angle ABC? Again, if you want to pause the video and go look for that, or think about that, or look at your options, that's just a picture. How do we know that? What type of angles are those? Maybe you know it if you're doing your angle puzzles, but you wouldn't know what they're called. They're vertical angles. So should we justify using the definition of vertical angles or the vertical angle theorem? So what's the difference between the vertical angle theorem and the definition of vertical angles? Well, the theorem usually goes and proves them congruent. So we're going to use the definition of vertical angles to say that measure of angle 1 is equal to measure of angle ABC. And at least I have a couple equations now. Maybe we can try to replace or fit those together somehow. So what can be replaced with what? Well, if 2 things are equal, they may replace each other. Maybe I'm going to go back and say if angle 1 is the same as ABC and A is the same as ABC, shouldn't that mean A and 1 are the same? And actually, when we said definition of equiangular angles, or equiangular triangles, you could probably leave that C in there. But you don't have to say all the angles are equal. We could just say any of them are equal. So I think I'm going to scribble out C here because I don't need that. If I do that, is it more obvious what we're going to be able to do? We can just replace measure of angle 1 with, well, okay, can't replace that with anything. We can replace A with something. No, but we can replace the ABC with either A or 1. So it doesn't matter which equation you want to choose. Maybe we'll choose, well, if I choose the second one, angle 1 would be on the left side. If I choose the first one, angle A would be on the left side. So maybe I'll do that because looking at what I want to prove, that's where we're going. So I'm going to rewrite that first equation. Measure of angle A equals measure of angle ABC. So instead of measure of angle ABC, we're going to say measure of angle 1. We're just replacing that with 1. And I'm in the right order. If not, I'd just use symmetric property, S little YPE, to switch it. And then lastly, change them to congruent, because that's the statement they wanted me to formally state in this formal proof. Definition of congruent angles. To prove something congruent, that means you have to show all the measures are the same. And with an angle, there's only one measure. So when you get that one measure, that is showing all of the measures the same. And by the definition of congruency, or what it means to be congruent, those 2 things would also be congruent.